terms of our review here, okay, and on the test, this is what you'll be told: solve, graph, set notation. The solving is the algebra. You can do this multiple ways. I'm going to stay with one way. I'm going to multiply everything by my denominator. I can't stress this enough. 7 divided by 7 is 1, and we're left with 3x. The 7's cancel. The common mistake is people want to put plus 4 is greater than 9. You have to distribute the 7 to all three terms. So plus 28 is greater than 63. And now I'm solving the algebra. We subtract 28 on both sides. And 3x is going to be greater than 63 minus 18. So that is, I believe, 35, right? And then we divide by 3, we divide by 3. The algebraic answer here is 35 over 3. Okay? Now, when I put it on my graph, this is not absolute value. I put 0 and I put 35 over 3 down. There's only one number to put down other than the 0. It's a greater than, so it's open dot to the right. And my set notation is parentheses around the 35 over 3 to infinity. And this right here is my entire answer. All right, you need the algebra, you need the graphing, and you need the set notation. My second one, I'm going to distribute. 6x plus 30 is less than or equal to 11x minus 17. With inequalities, we always move the x to the left. You're going to get yourself in trouble if you move the x to the right. So with an equal sign, we used to try and keep the x positive. With inequalities, get that x to the left, which means I got to move the 30 to the other side. And now I'm left with a negative 5x is less than or equal to a negative 47. I'm dividing by a negative, which means the sign is flipping. 47 over 5. My graph, I'm going to put my 0 in, my 47 over 5. It's a greater than or equal to, so the dot is closed. And my set notation is a bracket. 47 over 5 to infinity. And that is my answer. Okay, if you recall, when you had a fraction and it was negative, that negative stays in the numerator. A big reason for that is when I multiply through by the denominator, it's always positive. 7 divided by 7 is 1, and I'm left with the negative 6x. 7 times 5 is 35, and 7 times 16 is 112. We're going to subtract. Now, if you notice right there, it's imperative the 7 affects the 5 and 16 as well. Okay, even though they're not fractions. Now I'm going to subtract 35 on both sides, and I'm going to add negative 6x is greater than or equal to 77. Sounds right? Yep. We divide by negative 6, we divide by negative 6. When you divide by a negative, it flips the inequality. Less than or equal to, and it's negative 77 over 6. On my graph, I'm going to put that negative 77 over 6 to the left of 0. And it's a closed dot with an arrow pointing left. Since it's less than or equal to, it goes from negative infinity to negative 77 over 6, and that negative 77 over 6 gets a bracket. The next one, we're just subtracting 10 on both sides, pretty straightforward. Now, even though there's a negative on top here, when I divide by both sides, I'm dividing by a positive 4. So in this case, the sign does not flip. We just get x is less than negative 8. And on my number line graph, an open dot over negative 8 to the left, and it's all parentheses with set notation. And these are your answers. Circle them both up so we know exactly where we're at. All right, so now on to our word problem here. You make 4% commission on all sales you make for the company you're employed by. If you're paid a base salary of $40,000, don't get caught up with the dollar signs. You can do that later on. I'm making $40,000. How much do I need to sell each month if you sell the same amount of product each month to make more than $75,000 for the year? So I've got to be aware of what I'm answering here as well. $40,000 is my base salary for the year. I want to make more than $75,000. So it's just a greater than. Remember, if it was at least $75,000, it'd be greater than or equal to. But it's more than $75,000, so it's greater than. Okay? Now, with that being said, how else do I get paid? I get paid on commission. Since all this is yearly stuff, I want to keep it yearly for right now. I get 4% of all my sales. Okay, which is 0.04 times X. I'm going to subtract 40,000 on both sides. So essentially, to make more than 75,000 for the year, I need to sell enough where 4% of those sales gives me more than $35,000. So I divide both sides by 0.04, both sides by 0.04, and 35,000 divided by 0.04 is 875,000. So I need to sell more than 875,000 per year. Now, with that being said, now I got to answer my question. I'm not asking per year, I'm asking per month. I'm hoping everyone knows that there's 12 months in a year. So I take that 875,000 and I divide it by 12. And my answer is going to be $72,000, $916.67 per month. And that's what I need to sell if I want to make more than $75,000 per year. I need to get a number greater than this. So my X is greater than that. $72,916.67. That's how much I need to make per year. And actually, I shouldn't call it X because X represents the yearly salary. I would just say, actually, more than $72,916.67. Now, with an inequality, with a proportion, the key is this. The numerators have to stay on the same side. So the 8 comes here, and the 6 goes there. So 8 times 5x minus 3 is greater than 9x, is greater than 6 times 9x plus 2. And now it's what you've been doing the entire time. But with an inequality in between the fractions, it's imperative the numerators stay on the same side. 40x minus 24, 54x plus 12. And now I'm going to subtract 54x because I always want the x on the left side. I'm going to add 24 to both sides. And I'm going to get negative 14x is greater than 36. And now when I divide negative 14 on both sides, I reduce that fraction and I flip the inequality. You should always be reducing fractions. And there's my answer. X is less than negative 18 over 7. If you wanted to check that, since x has to be less than negative 18 over 7, x, if I put 0 in and that's greater than negative 18 over 7, that should create a false statement. If I plug 0 in here, I get negative 1/2. If I plug 0 in here, I get 1/4. Negative 1/2 is not bigger than 1/4, so it would be correct. Okay. Now, when we do absolute value signs with an equal sign, okay, the key is we get the absolute value alone first. We subtract 8. For absolute value of 3x plus 7 equals 24. We do not distribute through the absolute value. We divide both sides by 4, and we get 3x plus 7 equals 6. Once I get the absolute value sign alone with an equal sign, it's 2 equations. Do not be lazy. It equals the numbers negative, and then we write down the equation like there was no absolute value there. But you have to do 2 equations because you're going to get 2 answers. That's what's going to happen every single time. Okay? I'm going to subtract 7 on both sides. 3x equals negative 13. And we divide 3. My x is equal to negative 13 over 3. Here I'm subtracting 7 on both sides. 3x equals a negative 1. And my x equals negative 1/3. And those are my two answers. When you have an absolute value with an equal sign, you're going to get two answers every single time. We need to be prepared for that. And if you can plug them back in and check, negative 13 over 3 times 3 is negative 13. Plus 7 is negative 6. Absolute value negative 6 is 6. 6 times 4 is 24. 24 and 8 is 32. You can check all of that. All right, here I'm going to subtract 8. I got to get the absolute value alone again. Negative 2x minus 4 is equal to 15. And we divide by 5. Divide by 5. And I'm at negative 2x minus 4 is equal to 3. Now, once again, while an absolute value can't equal a negative, we can have as many negatives as we want in the absolute value. I'm setting up the same thing. 2x minus 4 equals negative 3. And negative 2x minus 4 equals 3. I add 4. Negative 2x equals 1. Divide by negative 2. And my answer is negative 1/2. Here I add 4. Negative 2x equals 7. I divide by negative 2. And my answer is x equals negative 7/2. And those are my two answers. Negative 1/2 and negative 7/2. You absolutely can plug them back in and check your answer. And it will work out.